So here we are on the first problem, and it's a warm-up of, it's called factor by grouping. I called it divide and conquer. Because if you can divide a person's army up into two parts and then just do one part at a time, it's so much easier to win. All right, so this factored out, and then look at the 5 factoring out here. Notice it's a positive 5. And then they come out the same. Did you get x minus 2 and x minus 2? Look at how they're exactly the same. Raise your hand if you got that far. Cool. Then those go to the front. You got x minus 2 in the front. And then what's left, I like to think this is dividing by x minus 2, dividing by x minus 2. Cancels, cancels. And that's what's left. So those go here. X squared plus 5. Now, this one didn't factor any further, but do you get, if this had been x minus 2 and then x squared minus 4, do you get, you'd have to factor it again? Just take a second. What does x squared minus 4 break up into?
Plus 2 minus 2.
Yeah, x plus 2, x minus 2. You guys remember that? So if you could have factored this, were you even thinking about factoring that? Because you should have been. That's going to be the most common mistake on the test, is people will get it factored to here, and then they won't even look and see if it can factor again. This one couldn't factor again, unless you want to use imaginary numbers, and that's way too complicated for this class. But if you had gotten this, don't forget, sorry, the x minus 2 can come down, and then this would break up into 2 parts. That's factored all the way. Okay, yes?
Isn't it plus 5, not minus 5?
It is. I'm saying this one can't be factored. But you're going to have ones on your test that are going to be like this. And then if it had been like this, it would have broken up again. So watch out for that. It's going to happen for sure. All right. So far you've done things like stick a 5 in, you know, f of 5. You remember how you just stick a 5 into everything and you get the answer? It's like a number. That's called evaluating. You've done adding polynomials, and look, I'm adding the like terms together. And there's it. That's my answer with all the like terms added together. We had subtracting, and that's where you have like a negative in front of the parenthesis. You remember how you had to distribute it? All right, and there's one last thing, is divide. And that's where, this one, we already did this. That's called factor by grouping. We talked about that already. This is the new thing. It's called long division of polynomials. All right, but to make sure you really get that, you got to get plain old-fashioned regular long division first. I know from experience that a lot of you have probably forgotten how to do this. So I'm just going to look at this one briefly and go, this answer wouldn't have been up here. The point of the problem would be to figure out that answer. So you go, does 12 go into 27? Yeah, it goes in there how many times? 12 times 2 is 24. And see, you go to 2 times this, 2 times the 12 is 24. Then you always do the opposite of this number right here. You might think of this as, I'm just subtracting, but it's a little overly simplified. You are doing the opposite of it, and you put these together and you get 3. And you bring down the 7, and now you have 37, and then you start the process over again. That's long division. I know it's been too long, so you should probably start with an easier one. Everybody go off to the side, please, and let's get that door shut, because there's some little people that don't realize there's other people in classrooms out there. So, is it David? Alec, sorry. Alex got the door, thank you. All right, so let's just do a simple one. 2 goes into 14. No, that's too easy. Because that'd just be 7, I'd be done, right? How about 15? We got to get long division down before we can do long division with polynomials. This unit's called polynomials. That's why we're doing this. We've added them. We subtracted them. We've multiplied them. Today we got to divide them. All right. Do you get that 2 goes into 15 7 times? Everybody put a 7 right there. Then remember that it's this times this. Well, 2 times 7 is 14. That's easy. Then remember, this is important distinction. We're not just subtracting today. we are combining these together, and we always have to make this number the opposite of what it was. See, sometimes today these numbers will be negative, and you'll change them to positive. In this case, would you agree the 14 is positive? We're changing it to negative. I know, you might be like, it's just called subtract, server. Well, later today, we make it the opposite of whatever it is. See, if that number's negative in polynomials world, that number could be negative, then we change it to positive. All right, now 14 and the negative 15, or sorry, the 15 and the negative 14 combine and make 1. So what is that? That's called the remainder. So if on the test, if something doesn't divide nicely, like you got a leftover, do you remember that's called a remainder? And that remainder, a lot of people don't really know, they just write R1. Don't do that. We got to be smarter than that in this class. Then our answer, if they just ask for the remainder, sure. If they ask for the remainder, the answer is 1. That is the remainder. Okay. But what does it really do? 2 times the 7 gets you close to your answer, right? The remainder gets added to that. See this? That gets added to it, and then you'll get up to 15, which is what we wanted. So it's this times this plus the remainder. All right, so let's see if you really got that. Here's another one that's similar. 3 goes into 11. You could do this. Would you agree it goes in there 3 times? You should be going, okay, 3 times 2 is 6. Oh, that's not enough. I can do another one. 3 times 3 is 9. Oh, cool. Like 9 seems to work. How about 3 times 4? That's 12. Oh, that's too much. So then it's 3. Please be writing this down. Most of you were. All right, now I'm going to go this times this. 3 times 3 makes 9. And then you're going to go make it the opposite of what it was. Don't just say subtract it, because sometimes they'll be negatives. That'll change to positives. This one ends up being 2, and that's the remainder. So that means 3 times 3 plus the remainder makes 11. 3 times 3 is 9 plus the 2 makes 11. You feeling like you're getting the long division thing? I almost sometimes think that we should just tell little kids that they can not worry about long division, and we'll wait till they're older, because you get it so much easier when you're older. So some of you guys probably never even got that before, but maybe you've already got it now. It just took like a couple minutes when you're older. It does make sense when you're older. You understand things faster. You can teach somebody. Heck, if you think of it this way, if you're as smart as you are now, how long do you think it would take you to learn 3rd grade math? You'd be able to learn it pretty quick. But it's better if you've already know 3rd grade math, right? So obviously it's one of these things where we need to teach you math, but maybe some of these really complicated things from elementary school you could just wait on. All right, so now let me just show you one last one that's got double digits, so it's going to be a little more complicated. 125 and 11 goes into it. Being honest, I have no idea how many times it goes in. I just made these numbers up. So I'm going to go, does 11 go into 12? Yep, how many times? 11 into 12. Once. 1 goes there. Follow along. Do this one with me at your iPad. If you're not touching your iPad, I can tell you're not doing it. So 11 goes into 12 once. Now, I go 1 times 11 is 11, and then I draw the line. Now you make it the opposite of what it was. I know, that just means minus, but later in polynomial world, it'll be an opposite thing. Then this is a 1, and then what do? We haven't even had this yet, but I think you might remember it. Can't just say the remainder's 1, it's not right. Drop the 5, very good. Somebody remembered elementary school. Okay, now you go, does 11 go into 15? Yeah, how many times? Once, so put a 1 there. And then again, it's this times this. 1 times 11 is 11. Make it the opposite of what it was. And I get 4. There's nothing else to bring down, then my remainder is 4. If all I asked was for the remainder, cool. You'd be done. But this really means that 11 times 11 plus the remainder of 4 makes the 125. This is 121 plus the 4 more, 125. Get how that worked? The remainder gets added at the end. All right, now we got to extend this to polynomials. So here's one. X squared plus 3x minus 4, and put that on the inside of the house. And on the outside, we put the thing we're trying to see how many times it'll go in. And we'll always tell you what you're supposed to divide by. So I'm going to divide this by x plus 4. Remember me saying that I disagreed with my colleagues about having this first? This is tough. Man, we're still in basically almost week 1 here. And we're doing something that we do in honors pre-calc. And we also do it in honors higher algebra, which is the class you're in. This is a tough topic, and it's always hard to teach even in those classes. So this is not easy, so pay attention. You can do this. We're going to put a number up here, and my advice to you is always start with an x. So I put an x up there. You know, if a teacher was teaching you regular long division, they might be like, try seeing if 2 goes in, you know? Like I'm saying, see if x goes in. Now here's what you do. You take that x and you multiply it by the thing on the outside. Because I'm going to just off to the side here show you how this is kind of like 2 goes into 13, you know. 2 goes in here 6 times, and then you go 6 times the 2 makes 12, right? Know what I'm talking about? Then this x has to be times by this, but it's actually 2 parts. So we got to go x times the x makes x squared. X times the 4 makes 4x. Draw the line. Remember me saying you make it the opposite of what it was? Instead of saying subtract. So I'm going to go opposite, opposite. Do you have any questions about where I got stuff? This blue x squared there, that came from the x times the x. And then we do the x times the 4, and that made the 4x. Now I've just made them both opposite of what they were. And now I add straight down. You know, just like on this problem, wouldn't I like put these together after I make it the opposite? Yeah, and in this case, I'd just have 1, and they'd be really easy. I'd be done. But these, of course, are more complicated. I'm going to add straight down, and I get 0 for this. Do you really have to write 0? No, because 0 could just be like left off. Those two cancel. And then what do I get when I put these two together? Negative x. Okay. Now I bring down something. Remember, we haven't done everything yet till we bring this down. So I'm going to bring down the negative 4. Notice there's 2 parts out here. So this has to have 2 parts here. All right, then the last thing is what goes on top. Now, after you've tried x for your first number, because that's usually the answer, then you try 1 and see if 1 works, but it's not going to. Let me show you. If I put a 1x, or put a 1 right here, positive 1, 1 times the x makes x, and I wanted it to make negative x. What should I have put up here?
Negative 1.
Negative 1, very good. that should have been negative 1. Negative 1 times the x now will make our negative x. Cool, it's matching exactly. And the negative 1 times the 4 makes negative 4. Draw the line. Do you get if I said before that we're not always subtracting? See, I said make it opposite and opposite. See how the negatives both became positives? And then everything's the opposite here. Negative x and positive x cancel. Negative 4 and positive 4 cancel. I got a 0 remainder. And that means that we just factored it, and x minus 1 times x plus 4 plus the remainder of 0. You can put plus 0 if you want, but it'd be kind of useless. That is that factored. That's just a different way to factor. That was really intense, I know. Now, to give some of you hope, the test that's coming right now is coming on Wednesday. I said it was either going to be Tuesday or Wednesday. I'm saying it, the earliest it'll be is Wednesday. And I'm going to talk to my colleagues tonight and see if we can afford to take an extra day so that we don't have to just review tomorrow and test on Wednesday. Maybe we can put this test off to Thursday, but I'm not promising that. The test is on Wednesday. And if you just can't handle this one topic, are you going to fail the whole test? No. But it'd be very hard to get an A on this test unless you can learn this. Okay? So, I'm going to give you 2 simple ones. 2 goes into 17. Do that one, and then do x plus 2 going into that. Do the 2 goes into 17 first, just to remind yourself how this thing works again. 2 times 6, is that right? No, that'd be 12. I can put in more than 6. 8? 2 times 8 is 16. Yeah, that's working. See how I can tell? I did this times this and I put it there. And then I got to do opposite. 1. Is there anything else to bring down? Nope. So the remainder is 1. Done. How many of you got remainder 1? Good. You get long division, which sadly is something that you should have known a long time ago. The question is, can you do this other one? And what did I say it always start with up on top? X. Can you pull that off? I'm going to pause for a second while you give that a try. So this is where I'm starting to get my feeling for whether or not you guys are getting this or not. So I'm just going to call on a random person, see if they can know what to do with that X. It is row 2, last person. Gotta get my signature. The last person is actually absent, so it's going to default to Karima. What do you think we should do with that X on the top? Yes! So I'm going to multiply this. This times this, and this times that. And what do I get?
X squared plus 2x.
Perfect. And did you put them like that? And draw a line like that? And then did you make them both the opposite of what they were? Ah, that's the next step. You got to make them the opposite of what they are. Because the x squared and the minus x squared is supposed to cancel out. And these two will then make 1x, or just x. Then you bring down the 2. Okay, what happened there? Okay, now, what goes on the top? I said the simplest thing to put first is an x, but then the next simplest thing to put is like a 1. So try putting a 1. Did you guys try putting a 1? Good. 1 times the x, x. 1 times the 2, 2. Look at that. Opposite, opposite. That's important because they don't add up to something. They add up to nothing. It works. I got 0 remainder. That means either if they just asked what's the remainder, you'd say it's 0. Or look, I factored it. X plus 1, x plus 2. Now I know some of you are like, I could have just factored that in the first place because I know how to factor. Well, cool. But I'm trying to teach you on simple ones because, of course, you don't start teaching a kid multiplication with like 4-digit numbers. You start with easy ones. So these will get big enough that you probably wouldn't have been able to do it. Like this one I could have factored without really having to try too hard. But the kind that we eventually give you on tests are the kind that would be pretty hard to factor without using this long division thing. All right. See if you've actually stepped up enough to be actually ready. This one is going to have a remainder. Like the remainder will be like 7. Or maybe it's even like 5x. Okay. Take this one, write it down, and put an x on top to start it. Let's see if you can do this. Hint. This has a remainder, so it's not going to like all work out perfect at the end. You'll have something down there like 2x minus 4. Or maybe it's just like 8. Aben, what happens with this x? Yes. And then you get x squared, and then what?
Plus 2x.
Excellent. Then, did you remember to put opposite, opposite?
Yes.
Cool. Then what did these make? The 5x and the negative 2x.
Would it be negative 3x?
Close, 3x. The 5 is bigger, so the positive team wins by 3.
Okay.
So positive 5 and negative 2 makes positive 3x. You'd have a calculator, don't worry, you could have used the calc. And then you got 3x, and then what? I stop? No. How many of you knew? Raise your hand if you brought the 1 down. Okay, that's a good sign. Most of you seem to be with me. Then what do you do? Do you remember me saying to try a 1 up here and see if it works? Well, how do you know if it works? 1 times x is 1x. Did that match up perfect? 1x and 3x aren't the same thing. Shouldn't have been a 1 up there. What should it have been? A 3. Because the 3 times the x would make a 3x, see? And 3 times the 2 makes 6. Draw the line, and if you're the type of kid who isn't like consistent and careful, this is going to be really hard. Then you got to remember to make it opposite, opposite. So it's really 1 and negative 6. Remainder was negative 5. Who had a negative 5 there? Now I just need to know, really, that was only 4 people? Only 4 people had that one right. Maybe 5. Okay. Look at it close. What is there any part you want to ask about? Like, why do we do that? Yes.
So would you always just add or subtract by the number, like the 3, or if it was like a 1?
I would start with a 1 right here and go, okay, I tried a 1, but it didn't work. How do you know it doesn't work? Because I go 1 times x is 1x, and I put a 1x right there. Or no, right there, and a 1x and a 3x aren't matching up. So you got to play with that number until you find one that works. Like 3 works because this 3 times this x makes 3x, and that matches up with this 3x. So that's how I know that it worked. All right, let's do one more like that. Ready? X squared minus 6x minus 7 divided by x plus 1. How did I say to always start? With x. Is x always going to work? No. But it's a good place to start. And then you go, this times this makes x squared, and it worked. How do I know it worked? Because the x squared and the other x squared match up perfect. Plus 1x. Who's careful enough to know what to do next? Put in the negatives. Okay. Negative here, negative here. These canceled, so then I know it's working. What's negative 6x minus x? That's a common mistake answer. It's not 5. Negative 7x. Really what that comes down to is what's negative 6 combined with negative 1. It's you're combining things. And I like to think of this as 6 on the negative team and 1 on the negative team, and that makes a total of 7 on the negative team. Okay. Again, I hate to be leaning on this so much, but you'd have a calculator, right? So you'd be able to put in negative 6. And if you say minus 1 or plus negative 1, either way, you're going to get negative 7. Okay, can I just get a help? Like, okay, I did this and it's all fine, and what am I missing before I can move on? Yeah, this comes down. Okay. Now, what did I say to start with here, but then you might have to change it? A 1. And 1 times x is 1x. Did that match up perfect with what I wanted it to match up with? No. So I'd change it from 1 into some other number. What would be a smart number? Careful. Minus 7. Very good. A lot of you are catching on, I can tell. Negative 7 times x will make negative 7x. And then the other one. Negative 7 times the 1 makes negative 7. Oh my gosh. This one actually, opposite, comes out to 0 remainder. It worked. What does that mean? That means the factors were x minus 7, which is this one, and the other one's x plus 1. Man, you guys are doing it. I mean, this is hard. I teach this in honors calc, or honors pre-calc, and honors higher algebra, and you guys are hanging in there. All right, see if you can handle it when it goes up one last notch. What if I said x to the third plus 3x squared minus 2x minus 6? Oh my gosh. Teach, you can't make us, it's not going to really be that hard, is it? There could be a question that's that hard. So let's long divide this by x plus 3. Wow. Okay, you remember me saying how to always start? X. But then you got to adjust. If I do x times x, that's going to make x squared. Is that matching up perfect? No. So change your x. And some people are going to say 2x, and then it's going to be like, no, because that makes 2x squared, and that's not what we want either. So it's not 2x. What is it? X squared. Very good. Because x squared times x will make x to the third. It's now matching up, and then you can know you're on the right path. And then x squared times the 3, 3x squared. Draw the line. Opposite. Man, so many little steps. Think of this as a super challenge. Like, if you can do this, I will be impressed. And you have a good chance of getting an A on this next test if you can pull this off. Do you get they're both exact opposites, so I get 0? Then this time I have to not just bring down one thing, I got to bring down both things. How do you know that? Because remember how I said if there's 2 things here, then there needs to be 2 things here. Okay. Oh, my head hurts. What if I put a plus 1 here? That's a good way to start, but you'll realize it's not going to work. Somebody has already tried it, and they probably know what to change it to. -2. Because -2 times the x will make -2x. See how that's matching up perfect? And then the -2 times the 3 makes -6. Oh my gosh, it's working again. It's working perfect. Opposite. I add them all up. I get 0 and 0. I got a 0 remainder. Cool. Then it's factored. into x plus 3, that's the one on the outside here, and this one, x squared minus 2. Now, did any of you even think about maybe factoring that again? Because if you thought about it, you win. If you are like, I wonder if that would factor, you win. Because that's the goal, is to factor it all the way. And a lot of kids are going to do all that work, and they'll have an answer like this, and they won't even check if it factors. And let's say on a different problem, again, this is a different problem. If I did all that work and I got it down to this, and I finally am done with my long division and I get this answer, you'll get it marked wrong. Because you didn't factor it the rest of the way. Which part can factor?
Yeah, squared.
Yeah, this part. And it could be into, I'm just going to replace this x plus 4 down here. The red ones would be x and x, I say three-step process, plus and a minus because I need a negative 16. And, come on, you can do it. 4 and negative 4, there it is. That's factored all the way. If you leave it like this, you're going to be in pain on the test because you'll be like, oh, I got it so close. I just had to factor it one more time. All right. I know this is some serious math. This is probably the hardest math you've done, since the beginning of the year. Like this might be harder than anything from the whole first semester. But for some of you, you're going to be like, I kind of like this. I got this. This is not that hard. All right. I feel good about that. It was 30 minutes to teach you that. I can tell because the video is still running here. But let's see if you've got it enough to handle the last couple slides. 44 divided by 3. Do you know which one goes in the little thing? Which one goes inside? The 44. That's called the dividend, by the way. We're not going to test you on that. And this 3 is called the divisor. I remember it because, like a bear climbs in a den. Dividend. Get it? I know it's kind of dumb, but there was this one family in Colorado, and they like were outside one day and heard something and realized, holy crap, we have a bear that has decided that their deck, underneath their deck, was going to be its den for the winter. So they have like a giant grizzly bear hibernating underneath their deck. I mean, it's kind of cool, but a little scary too. All right, let's move on. This is long division with polynomials. Which one do you think is the dividend and goes in the den? I hope you were thinking the x squared plus 2x minus 3, because it's the bigger one. Basically, the bigger one goes inside there. And the x minus 1 goes out here. Now, can you do it? I can do it. It's can you do it? I'm going to pause for a second. This is the true test. Did you learn anything from me? See if you can do this. I'll pause. I'll give it a shot. Okay, let's see who's got it, who has a chance at an A on this next test. You could still get an A without this question, but you'd have to get all the other hard problems right. If you can't do this one, you'd have to be like perfect on everything else. All right, so let's see. I would have just said to start with an x, and then I go x times x makes x squared, and it's all looking good. And then I go x times the negative 1 is negative 1x. Draw a line, opposite, opposite. See why I don't say just subtract? Because look, now it's going to turn into an add right there. It was a negative, now it's a positive. That makes this a 3x. Bring down that minus 3, and then start with a 1 and see where it goes. Like if I start with a plus 1 here, I go 1 times x is 1x. 1x is not going to make it work nice. So don't use a 1. Use 3. How many of you had an x plus 3 up on the top? Cool. I've got quite a few people that would have passed this one. 3x and then minus 3. Draw the line opposite, opposite. And these add up to 0 and 0. There's a 0 remainder, which means the factors were this and this. X plus 3, x minus 1. Okay, I know that was kind of an easy one, but be honest, how many of you feel like you could get that right on a test? All right, cool. It's a lot harder to do the ones that are like significantly bigger, like this. I'm just gonna do this one really quick just to show you it wouldn't be that hard. You start with an x and you go, that's not working because I get x squared, but I should have got 4x squared. Then you go, oh, I guess I could use a 4x. 4x times x makes 4x squared. 4x times the negative 2 makes negative 8x. Draw the line, opposite, opposite. It adds up to 9x. Start with a 1, but then go 1 times x is 1x. Oh, that's not working. Use a 9. 9 times x, 9x. 9 times negative 2, negative 18. Oh, wait a minute. I forgot to bring down the negative 14. It's not too late. I can still bring it down now. And then I draw my line. Opposite, opposite. Makes a 4. No, she's leaving. Don't worry, it's not class over. She just asked me ahead of time if she could go. Do you get this one had a remainder of 4? Did anybody get a 4 before I even said it? Okay. Why does it have a remainder of 4? Because when you put these together, you get 4. And that's the remainder. And there's nothing else to bring down. Like, I can't bring anything else down. So then there's a remainder 4 on this one. That make sense to you? Okay. All right. I think we've done enough practice. Let's get to the actual homework problems. So there's a worksheet. It's called that, and I'm going to go find it, and I'm going to pause while I do. On the worksheet for today, we're just going to do the odd ones. So, of course, that starts with number 1. Karima, could you read me number 1? Okay, hold that thought a second. We're going to get that first problem started, including you. And then there's a couple people who want to use the bathroom, and that's fine. But you got to get started on the homework first. Let's have, do you have the worksheet open? Could you read me number 1?
X with x minus 3 plus x minus 2 plus 2x plus 2.
Thank you. And I think this is just that factor by grouping stuff, right? So, the line like that, factor the first part, x squared comes out. That's really dividing by x squared, dividing by x squared. Did you get x plus 1? That is how you'd start at least. And then, see how there's a 2 in both of those? Factor out the 2. And you get x plus 1. That's not a coincidence. These are exactly the same. So those go to the front. And these go at the end. Did anybody even look at this part and say, I wonder if it would factor again? Because if you did, then you win. Because that's what's going to happen on the test. And a lot of people aren't going to even look. They're going to just think, I'm done, yay. But if this part would have factored again, you would have to factor it. Okay, moving on. To number 2? No, we're doing odds. So what's next?
3.
Number 3. Let's see. Row 4. First person, Victoria. Read me number 3.
91 divided by 7.
91 divided by 7, like this. Oh, sweet, nice easy one. I put 7 goes into 9 one time. 7 times 1 is 7. Make it the opposite. 9 minus 7 is 2. Bring down the 1. See how it's a lot like, it's got the same kind of things as polynomial log does. And then I go, what goes here? And then, oh yeah, 3 goes there, because 3 times 7 makes 21. Draw the line. Okay, draw the line, and we'll subtract that, and then you get 0, 0 remainder, sweet. So that means 7 times 13 is your answer. 7 times 13 makes 91. Most people wouldn't have been able to do that in their head, but with the long division, you can. All right, so that was number 3. On to number 5. I'm hoping it's a polynomial long division, so that's because that's what we're supposed to be practicing today. David, in the back corner, would you read me number 5?
X squared minus 9x plus 18.
Is it like divided by something? Oh, okay,
divided by x minus 3.
divided by x minus 3. I'm gonna erase my problem 5 here. Make more room. Okay. Oh, we'll start with an X there, right? All right, so this is your homework. If you need help, I will help you. Opposite, opposite. The one kid who's asked me a question so far, it was forgetting to do the opposite, opposite thing that got them. So please feel free to come up and ask me for help. That's where we are on this problem. And that's all I got for the video for today.